Hi everyone, I'm Alyssa May Echon from Visayas 3A. So today we'll learn how to create a linear optimization model, implement them in Excel, and solve them using Solver. So, so in this session, we'll break down the concepts, explore step-by-step methods, and even see how Excel Solver can do the heavy lifting for us. So by the end, you won't just understand the theory, you will know how to apply it to real-world problems efficiently and confidently. So grab your notebook, open your spreadsheet, and let's optimize our learning properly. Discussing the concept of linear optimization, also known as linear programming. So, what is linear optimization? Linear optimization is a mathematical method used to determine the best possible outcome when we are working with our limited or scarce resources. So, in other words, whenever we need to make the most efficient decision, whether it's maximizing profit, minimizing costs, or optimizing any measurable object, linear optimization provides a structured way to do that. So this method is widely used across many fields. Like for example, in business, it can help determine the most profitable product mix. While in accounting and finance, it can guide decisions on budgeting, portfolio selections, or minimizing operating costs. And also in logistics, it helps us identify the most efficient routes or distribution plan. So, what makes linear optimization powerful is that it translates real-world scenarios into mathematical models using decisions variables, objective functions, and constraints, allowing decision makers to find solutions that are not just good but optimal. So by the end of this topic, you will understand how linear optimization works and why it is such an important tool in analytical decision making. So now let's move on to the four-step process for developing an optimization model. Framework we follow whenever we want to translate a real-life decision problem into a mathematical model. So first step, we have defined the decision variables. The first step is to identify what decisions need to be made. So these are represented as variables in our model, like for example, how many units of a product should be the company produce, or how much of each resources should be allocated. So these are the variables will later be used in the objective functions and constraints. So it's important to define or identify them clearly. So next we have the step 2, write the objective functions. Write the objective function. So next we create the objective function. So this is the mathematical expression that represents our goal, whether we want to maximize something like profit or output or minimize like our cost or production time. So a key point to remember for this phase or step 2 would be the objective function must be linear, meaning the variables appear only in simple terms without exponent or nonlinear relationships. So for third step is to formulate the constraints. So after defining the objective, we create the constraint. Yung constraints is represent the limitation or restrictions in the problem. It includes yung budget limitation, available labor hours, material quantities, or production or storage capacity. So yung constraint ensure that the solution we find is realistic and achievable within the available resources we have. So step 4 or the final step would be add a non-negativity constraint. So finally, we add the non-negativity constraint. So this simply states that our decision variables cannot be negative. Like for example, producing a negative number of units, that would be impossible. So we make sure all variables are greater than or equal to 0. And that completes the first step process. So by following this structure, we can systematically convert real-world problems into models that can be solved mathematically using linear optimization. Discuss how to actually implement an optimization model using Microsoft Excel. Excel is one of the most accessible and widely used tools for solving linear optimization models or problems, especially when paired with the solver add-in. So to start, we follow a structured setup process inside the spreadsheet. So number 1, we have organized the data in the spreadsheet. So this is the first step is to properly organize all the information needed for the model. So in your Excel file, you should prepare a section for decision variables, coefficient for the objective functions, and coefficient for the constraints. So next is to create dedicated cells. So we create specific cells for the components of the optimization model, which are the cell for decision variable, a cell for objective functions, and cell for each constraint. So for third is to use Excel formula. So after arranging the model, we use Excel formulas to automatically compute the objective function value and constraint values. Like for example, we often use sum product to multiply coefficients by decision variables. And that's the core process for implementing optimization model in Excel. So with these setups, you're ready to run a solver and find optimization solution. We've run a solver, and here's what it gave us. A total profit of 2,800 pesos. So this is the maximum profit we can achieve with the resources we have. So any combination outside those numbers either violates the constraints or lowers the profit. Next, we have possible solver outcomes. So solver may provide a optimal solution found wherein model satisfies all constraints. And next is solver could not improve the current solution because current solution is already optimal. And next is unbounded solution wherein constraints do not prevent the objective from increasing infinitely. And lastly, it may provide no feasible solution because constraints contradict or prevent any valid solution. So that's it. To conclude our discussion, linear optimization is a foundational analytical tool that supports a wide range of decision-making activities, and it plays a crucial role in resource planning, cost minimization, profit maximization, and allocating and scheduling decisions. So by modeling problems mathematically, linear optimizations allows organizations to make a smarter, more efficient, and more consistent choices. So what makes this even more practical? So it is the availability of Excel Solver because Solver brings the power of optimization into a familiar spreadsheet environment. So making it easier for us, a student, businesses, and professionals to create or test and solve optimization models. So with Solver, linear optimizations become not only accessible but also highly effective for real-world decision making. So hi everyone, again I'm Malaysa May Etchan. So thank you for your attention throughout this discussion on linear optimization model and Excel Solver. I hope this presentation has provided you with a clear understanding of how optimization models work and how they support informed decision making in various fields. So as future professionals, being able to analyze constraints, structure models, and identify optimal solution is an essential skill for us, and tools like Excel Solver make that process accessible and practical. So once again, thank you for listening, and I hope you gained valuable insights from this session.